Okay, so in this video we're going to be talking about our quadratic equations, and in specifically we're going to be talking about vertical shift. Okay, so all that vertical shift means is basically we're going to be taking our standard graph of y equals x squared, and we're going to be vertically shifting it or vertically moving it up or down. Okay, so vertical meaning up or down, shift just meaning we're going to be moving it. So we're going to be taking our traditional equation and we're going to move it upwards or downwards, and we're going to see, how that affects our equation and what happens with that. So again, similar to how we had with y equals x squared, what we can do is we can just make a few tables and see what kind of points we get. And in this case, we already know what y equals x squared looks like, so we don't need to worry about y equals x squared. But let's make some adjustments to y equals x squared and see what happens. And the first equation we're going to take a look at is actually going to be y equals x squared plus 2. And we're going to see what happens when we do that. So with y equals x squared plus 2, again, we'll make our table and we'll have a y and an x variable. And we're just going to take a few points down and see what we get. So again, we can do from +3 to -3 like we did with y equals x squared, but let's just do +2 to -2. So 2, 1, 0, -1, and -2, and just see what we get. So when x is equal to 2, we're going to get y equals 2 squared plus 2. So 2 squared is 4, 4 plus 2 is 6. When x is equal to 1, we're going to get y equals 1 squared plus 2. 1 squared is 1. 1 plus 2 is 3. Okay, when x is equal to 0, that's really nice because this x squared term just becomes 0. So we're going to get 2. And now we have two ways of going about these other two. We can either just do the math, or we know that since quadratic equations are symmetrical, we already know what these values are going to be, but let's just double check to be sure. So with -1, we get -1 squared, which is just 1. 1 plus 2 is 3. And with -2, we get -2 squared, which is 4. 4 plus 2 is 6. So we can see that symmetry about the point x equals 0. And the other equation that we're going to take a look at is going to be y equals x squared minus 2. Pretty simple. And we'll be able to graph these and see how these changes in our y equals x squared equation compare. So again, we'll go from 2, 1, 0, -1, and -2. Again, when x is equal to 2, we get 2 squared, which is 4. 4 minus 2 this time is 2. With 1, we'll get 1 squared, which is 1. 1 minus 2 is -1. With 0, we get -2. With -1, we're going to get -1 squared, which is just 1. 1 minus 2 is -1. And again, with -2, we're going to get -2 squared, which is 4. 4 minus 2 is 2. And again, we see that symmetry about x equals 0. Okay, so now that we have these equations, as well as we have our traditional equation of y equals x squared, which again, we already know what it looks like, we can graph it on a piece of graph paper and see what it looks like. So if we were to graph it, this is the equation that we would get. Or sorry, these are rather the graphs that we would get. Okay, so let's quickly go ahead and label them. First, we'll label this red one because we're probably most familiar with it. There we go. Put some arrows at the end of it, and we'll label it as y equals x squared. We know this one, we've seen it in the previous video, so we're pretty comfortable with this one. If we take a look at this blue one, this blue equation is going to be the equation of y equals x squared. And now we need to decide if it's +2 or -2. The way we can do that is we can take a look at our two tables here and see what points are in this blue graph and how they compare to this table. So if we take a look at some of the points here, we see the point 2 comma 0, we see the point 1 comma 3, we see the point negative 1 comma 3, and if we look at these tables on the left, we'll see that that corresponds to this top one, and that equation is y equals x squared plus 2. Now, of course, when you do this, you'll have to actually put the points on here and connect them. I've just done that beforehand. And the last equation that we have here is this green one, and this green equation is just going to have equation, well, it's the only one that's left, and it's y equals x squared minus 2. Okay? And so with this, we can again go ahead and start analyzing these. And what we'll see is that they have a lot of similar features, but there are some different ones. For example, we can talk about the axis of symmetry for all of these. So the axis of symmetry for all of these is the same. Okay, so the axis of symmetry for all of them is the same. It's going to be this line running down the y-axis. Okay, and we can just visually see that again. If we just take a look at it, we know that that's where the axis of symmetry is. And again, what is the equation of this axis of symmetry? Well, it's at x equals 0. So what we can comfortably say is that for all of these, the axis of symmetry is at x equals 0. And I'll write them down in our separate colors so that we can keep track of them. And x equals 0. Okay, great. That's our axis of symmetry. What about our vertex? Well, remember, our vertex and axis of symmetry are related, but it doesn't necessarily mean that they are the same. So if we take a look at this blue graph, remember the vertex is either the lowest or the highest point of a quadratic equation or a quadratic graph here. And in this case, since all of these open upwards, we know that it's going to be a minimum. And that minimum is located right here. Okay, so this is the vertex for this specific equation, y equals x squared plus 2. And the vertex, well, where is it located? It's located at this point, and this point is has an x-coordinate of 0 and a y-coordinate of positive 2. So the vertex for the blue graph, y equals x squared plus 2, is going to be 0, comma 2. The vertex for our red one, on the other hand, is going to be right here. Okay, it's going to have the same x-coordinate. Let me label it as the vertex. It's going to have the same the x-coordinate as the blue one, in this case 0, but the y-coordinate is also going to be 0. Okay, so 0 comma 0, that is our vertex for y equals x squared. And finally, for our last one here, the vertex is going to be down here all the way at the bottom. Okay, and we can label that as the vertex as well. And again, the x-coordinate is the same, it's 0, but the y-coordinate is negative 2. Okay, so 0, comma, negative 2. And what we can see here is that with any of these three graphs, we can see that this this positive 2, this 0, and this negative 2 may have some relationship with what we're adding on after our x squared, right? So y equals x squared plus 2, and we can see what happens to the y-coordinate of the vertex. Y equals x squared minus 2, and we can see what happens to the y-coordinate of the vertex. Okay, it changes. And we also have y equals just x squared plus 0, and we can see what happens to the vertex there. So what we can say confidently is that if we have some sort of constant that is being added or subtracted from y equals x squared, then we know that that is going to be our vertical shift, or that is going to be how much our graph is shifted either upwards or downwards, depending on if it's an addition or a subtraction. So that's good knowledge. That's something good that we want to have. Okay, and we can actually identify that shift by taking a look at our base graph here and seeing how the blue graph has now, gone up a certain amount of units. In this case, plus 2, and the green graph has gone down a certain amount of units in this case, minus 2 if we were to just draw a line there, seeing where we go to and connecting it to the vertex of our original graph y equals x squared. So this is this plus 2 and minus 2. This is your vertical shift, either upwards or downwards. But there's other things that we can talk about with these equations. For example, the x and the y-intercepts. So let's talk about the x-intercepts in this case. And again, if we look at the blue graph, we'll see that, so we ask ourselves, where does this blue graph cross the x-axis? Well, it's above the x-axis and it opens up, okay? So if it's above the x-axis and it opens upwards, that means it's never going to get lower than its vertex or than its lowest point, okay? And its lowest point right now sits at y equals 2, so, and obviously just by looking at this graph, we can see that it's never going to cross the x-axis. So the x-intercept, we just say there's none. There is no x-intercept for the blue graph, okay? Take a look at the red one, and again, we covered this in the previous video, but the x-intercept for the red graph is right here. It happens to be at the vertex, okay? So this is the x-intercept. And again, we can label where this x-intercept happens. It happens at x equals 0. So our x-intercept for the red graph, y equals x squared, is at x equals 0. And finally, if we take a look at the green graph and where it crosses the x-axis, we can see it actually crosses at 2 points. It crosses right here. Okay, so this is an x-intercept. And it also crosses right here on the right-hand side. And this is also an x-intercept. Okay. And now, of course, with math, we don't want to guess. We want to be certain. But if you really want to, you could how can you check where the x-intercept happens? Well, it happens at y equals 0. So what you would do is you would substitute in to the equation y equals x squared minus 2. You'd substitute in a 0 where the y is, and you would get 0 equals x squared minus 2. And if we solve that, we'll go 0 equals x squared, and then we'll take the square root of both sides. Square root of x squared just becomes x, right? So that's just going to be x if we take the square root of both sides, and we'll take the square root of 2. And remember, when you take the square root, you gotta put a plus minus. You can have a positive or a negative. And so this is going to be the square root of 2 plus minus the square root of 2. That's going to be our x-intercepts. So of course the one on the left here is going to be x equals negative root 2. And on the right here, we're going to have x equals positive root 2. Okay? And so we can write that here. The x-intercepts, there are 2 for the green graph. There's x equals negative root 2 and positive root 2. We can get decimals for this if we want, but we'll just leave it as positive and negative square root of 2. And finally, the last thing that we have here is the y-intercept, or where these graphs cross the y-axis. And if we look at the blue graph, we'll see that it happens right here where the vertex is. Okay, so that is the y-intercept. And we ask ourselves, where does it happen? Well, it happens at y equals 2. And so we'll write y equals 2 for the y-intercept. For the red graph, again, we went over this, but it occurs right here. This is the y-intercept, and it happens at y equals 0. So we'll write that down. And finally, for the green one, it happens right over here. This is the y-intercept, and it happens at y equals negative 2 in this case. So y equals negative 2. Okay? And you'll see again that there's a correlation with the y-intercept as well as what we are adding or subtracting here. So again, the plus 2, and the minus 2, and the minus 2. And again, we have y equals x squared plus 0, and that's where we get this middle value for the green graph. Okay, so again, these are all things that we've talked about before, except now we're just applying them to graphs that are slightly transformed. In this case, they are slightly shifted vertically, either upwards or downwards. And as you can imagine, we have these vertical shifts, but we can also maybe have a horizontal shift. And that would, of course, make the graph go to the right or to the left a little bit. And so that's what we're going to be covering in the next video.